Okay, so this is the second of two volumetric or titration videos, and it follows directly on from the ones we were doing just before, where we were looking at reacting two solutions together. This question here is slightly different. You're reacting a solid, magnesium, with a solution, which is nitric acid. Now usually in these questions they would give you the equation, but I thought for the final question we would work out actually the products that were formed. So here you've got a metal and here you've got an acid, and hopefully you should remember that a metal plus an acid gives salt and hydrogen gas. Now hydrogen gas is H2. Now the question you hopefully are asking yourself now is, well, what actually is a salt? And in an earlier tutorial we covered the fact that a salt is an acid that it's had the hydrogen ion, or the hydrogen, removed, and that hydrogen has been replaced with a metal. So the name of the salt we're producing here is magnesium nitrate. And we need to think about the formula of magnesium nitrate. Now hopefully you should know that magnesium is in group 2 of the periodic table, so it would have a valency of 2. Unfortunately nitrate you can't find in the periodic table. You need to learn that nitrate is NO3 and it has a valency of 1. And you should have learnt that when you're writing a formula you swap the valencies over, so we would need 1 magnesium and 2 nitrates, and that would be written as Mg brackets NO3 close brackets 2, and that would be the salt that we formed. I'm going to rub this out to allow me room to do the actual question. And before we start, really what we should also do is put on the board the 2 moles triangles that we're going to use. So here's one, as you can see, very, very neatly written. The first one using masses of substances, so we'll have moles is mass over RFM, and the second triangle, which involves solutions, is moles is concentration times volume. And we should know that our units for concentration are moles. I'm not quite sure why I've managed to fail trying to M correctly. Moles per decimeter cubed, and the volume is decimeters cubed. So let's get the question done. Let's organise our data. We're asked for the mass of magnesium, and we're told that the volume of nitric acid is 50 centimeters cubed, and we're told the concentration is also 2 moles per decimeter cubed. And hopefully you'll remember that the calculations were in 3 parts. In the first part we worked out the moles of a substance, and in this case we're going to work out the moles of nitric acid because we have volume and concentration. So moles equals volume 50 times concentration, which is 2, and you should be hopefully familiar with the fact that you need to convert centimeters cubed into decimeters cubed, and we do this by dividing by 1000. Okay, so you may put that into your calculator if you want to, you may not, but that comes out as 0.1. Now that's the moles of HNO3. Now just looking at that equation at the top, you should hopefully see that it isn't actually balanced. It isn't actually balanced. It can be balanced very quickly, very easily, by putting a big 2 at the front there, and really that's what we should have done when writing the equation to start with. But that tells you that for every 2 moles of nitric you need only 1 mole of magnesium. Now we haven't got 2 moles of nitric, we've actually got 0.1. okay, but using the 2:1 ratio we can show, or we can see, that moles of Mg is 0.1 divided by 2, which comes out as 0.00 fact, not 0.00, just 0.05. So that's the second part of our calculation done. We now need to finish it off. So the question has asked us for the mass of mg. And the mass of mg can be worked out using this triangle here. Okay, so mass, moles, RFM. So mass equals moles times RFM. So the moles is 0.05. And you can now get your periodic table to work out the atomic mass, or the relative atomic mass of magnesium, which is, if you can just find it, 24. Okay, and if you plug those numbers into your calculator, it comes out as 1.2 grams. And that's your final answer. So you can see that it is possible to do calculations where you have a solution and where you have a solid. So here we know that exactly 1.2 grams of magnesium reacts with this amount of nitric acid. And that's the end of this video.